All right, here's my third video from section 4. This is of the second redesign practice test. So this is the calculator section. I'll pick up here on problem 21. So in prior videos, I did 1 through 10 here, and then 11 through 20. So 21, a project manager estimates that a project will take X hours to complete, greater than 100. The goal is for the estimate to be within 10 hours of the time it will actually take to complete the project. If the manager meets the goal and it takes Y hours to complete the project, which of the following inequalities represents the relationship between the estimated time and the actual completion time? What we're saying here is that X and Y have to be close to each other, right? They have to be within 10 hours of each other. The difference between X and Y has to be small. X plus Y has to be less than 10? No, not at all. Whoops. Don't circle it when it's wrong. That's certainly not the case. Y has to be greater than 10 more than X? No, that doesn't make any sense. Y has to be less than 10 less than X? No, that doesn't make sense either. D here, either by process of elimination or because this difference right here, Y minus X, has to be a small number. It has to be either less than 10, actually it has to be less than 10, and also greater than negative 10. It has to be some number between negative 10 and positive 10. D would be the answer there. What about 22? Which of the following expresses the square? Actually, you don't even have to read this, right? It tells you that I equals P over 4 pi r squared. And then down here you see a whole bunch of r squared equals things. I guess I'm going to try to solve this thing for r squared. So I want to get this r squared thing here all by itself up on the top of the fraction. It's down on the bottom here now. So maybe I'll multiply it up to the top. I'll multiply both sides of this equation by r squared. That would give me I times r squared is equal to P divided by 4 pi. But I don't want I times r squared, I just want r squared. So I'll divide both sides of the equation by I, and that'll give me P divided by 4 pi I, something like that. So I'm looking for that guy over here, P over 4 pi I. Looks like B is a winner. 23. For the same signal emitted by a radio antenna, observer A measures its intensity, which is I, to be 16 times the intensity measured by B. The distance from A is what fraction of the distance of B from the radio? Well, R here talks about the distance. So really what it's saying is that if I is 16 times greater and P is the exact same because it's the same radio antenna, what can you say about the ratios of R? Well, if I is 16 times greater, well, then this entire fraction is 16 times greater, which means that the denominator is 1/16 because everything else stays the same. So the entire denominator of one of them is 1/16 of the other one, but it doesn't want to know about the denominator. It wants to know about r squared. Well, 4 and pi stay the same, so r squared is 1/16 from the other one. But it doesn't want to know r squared, it wants to know r. So r squared, kind of its ratio, is 1/16. So that tells you that r's ratio is 1/4. If you're trying to do this the quick way, I guess you'd reason through it like that. A more complete sort of algebraic way to do this problem is you could say, so for one person, maybe the intensity of person A is 16 times the intensity of person B. So the intensity of A is equal to 16 times the intensity of B. So I got the intensity of A, which is equal to P over 4 pi R for person A squared. And then I have the intensity of B, which is equal to still P because it's the same radio, over 4 pi R for person B squared. And what I want is the ratio of persons B to A, I think this is. What fraction of the distance of observer B? So if you go through and solve this, A is 16 times that of B. So instead of IA here, I could write 16 times IB. And that's equal to 4 over pi, P over 4 pi R A squared. And then I got IB is equal to P over 4 pi RB squared. So if I multiply both of these by 16, both sides of this equation, Then I have the same thing here and here, so I can set these two guys equal to each other. Maybe down here. So what I get is that P divided by 4 pi RA squared has got to be the same as 16 times P divided by 4 pi RB squared. Well, I could divide both sides by P and that would go away. I could multiply both sides by 4 pi and that would go away. So what I have is 1 over RA squared is the same as 16 over RB squared. And then you go through and read this one last time. The distance of observer A from the radio is what fraction of the distance of observer B from the radio? Well, the way I could figure that out is I could divide both sides by 16 to get 1/16, and then multiply both sides by person A to get here. And RA squared over RB squared is the same as RA over RB squared. So I could take the square root of both sides and get 1/4 is equal to RA over RB. Here's how you could do it algebraically and talk yourself through it. But I think on a test where time is of such importance, it would help you to kind of think about it a little bit more. And really the way to think about it is that the distance squared is proportional to the change in intensity in this equation here because this is being squared. So if the change in intensity is 16, the distance squared is a ratio of 16. But you don't want to know distance squared, so this isn't the answer. So your answer comes down to, well, it's either 16 squared or the square root of 16. So either I get 1/4 here, or 16 squared gives you this 256. So those were really my only two possibilities for this guy. But then if you look at it really carefully, you'll see that it's the square root that I'm interested in because I'm interested in the distance, and I'm given the distance squared. So this is not the answer, that is the answer. 24. The equation of a circle is shown above. What is the radius of this circle? Okay, this is what is called completing the square, which is kind of unexpected perhaps because we're talking about circles, not squares. The way you do this is you grab your x terms, put those next to each other, then leave yourself a little bit of room. Grab your y terms, put those next to each other, leave yourself a little room, and then put a -1. Put this number way the hell over here. And your goal is to make this a perfect square. To make this a perfect square, you need a number right here. You end up needing the number 4. If I'm going to just add it right here, I better add it to this side of the equation as well. How do I know this is 4? This number is always going to be half of b squared, where b is the coefficient on your linear term. It's this 4 right here. So I take this 4 and I cut it in half, and I get 2. And then I take that 2 and I square it, and I get +4, which is what I wrote right here. Same idea over here, except now b is -2. If I cut that -2 in half, I get -1. If I square that -1, I get +1. So I'm going to add 1 to both sides of the equation. This is now a perfect square, and this is a perfect square. You don't have to rewrite these, but you could. This is x plus 2 squared, and this is y minus 1 squared. Don't believe me that this is x plus 2 squared, and this is y minus 1 squared? Foil this out. Foil this thing out, you'll get exactly this. In order to factor this as a perfect square, you're missing this 4, which is why I put it in. At any rate, you end up not needing either of these. All you need is the number on this side of the equation, which is 4. I bet 4 is a possible answer. It would be tempting to put in 4, but you don't want 4 because the standard form of the center of a circle is this guy, of the equation of a circle. The center of the circle is at k comma h, so this circle is centered at -2, +1, because I want k and h. But I'm not asked any of that. I'm asked for what the radius is. Radius squared is over on this side of the equation. So I got radius squared equals 4, but I don't want to know the radius squared. I want to know the radius. So the radius is equal to the square root of 4, which is 2. A is the correct answer here. All right, one more. The graph of the linear function f has intercepts at a, 0, and 0b in the xy plane. If a plus b equals 0 and a is not the same of b, what can you say here? Okay, if a plus b equals 0, That means A and B have the same magnitude. They're the same value, just one of them's positive, one of them's negative. And they're not the same value, so they're not both zeros. So A maybe is positive. If A is positive, then, oh, I guess that would be over here. I get A 0. If that's the case, then B is negative. So I would get 0B right here. This is one possibility for my line. Another possibility is that A is negative, in which case it shows up here, in which case B is positive, and so that would show up here, and I get this line. So these are my two possible lines. I don't know which of these two lines it is, but it's one of these two. So which of the following is true about the slope of the graph of f? What do these guys have in common in terms of their slope? Well, they're both positive. That's my answer. It is negative. Nope. It equals 0. Nope. It is undefined. Nope. My answer would be A.